All right, so let's do some examples for permutations and combinations. So we are now on page 22. This is the page for the permutations and combinations, page 21, and the examples will be on page 22. So in the first example, what you have is the free press wants to scramble the letters of the word justice, and how many ways can they be scrambled? And if you think about scrambling letters, J-U-S-T would be different than J-S-T-U and so on. And so therefore the order matters, and so therefore we need to use a permutation. So that's the first thing that you have to identify, the fact that we need to use a permutation. Now the next thing that you need to identify is the total number of letters that you can choose from. And the second thing that you have to identify is how many letters are you choosing. So justice has 7 letters. And if you want to scramble all the letters, then that means that you have to select or choose 7 letters out of those 7. So N is 7 and R is 7. And so therefore the permutation would be a permutation of 7 letters out of 7 letters. A permutation of 7 letters from 7 letters. And so here is what you would get. 7 factorial divided by 7 minus 7 factorial. But again, you do not need to worry about writing this out. You need to be able to put this into a calculator. So you have 7 and then the permutation button, and then 7 again, press the equal sign, and you should get the answer of 5040. Now this is the same thing as 1, 2, 3, 4, 5, 6, 7 with 7, 6, 5, 4, 3, 2, 1 again, because you are scrambling 7 letters. For the first letter you have 7 options. Once you've chosen one, you don't have 7 anymore for the second letter, but you have 6 for the second letter, and so on. And when you multiply those together, you get the number of ways that you can arrange the 7 letters. And that is also the same thing as just 7 factorial. So the answer is 5040. If we assume that justice can't be one of those possibilities, then there would be only 5039 ways to scramble the letters. Now, the second example, a baseball coach must choose 9 out of 15 players to start the game. So the question asks, how many groups of 9 can be chosen from those 15? Well, since he's choosing groups of 9, and I don't care within those groups in which order they are, therefore we don't have a permutation, but we have a combination, because the order doesn't matter within those groups. And so in this case we have a combination where the total number of options is 15, but I only choose, or the coach only needs to choose 9 out of those 15. And so N, the total number is 15. R, the number of items to choose are 9. And so we have a combination of 9 from 15. And that would be this, the formula would be this for that. 15 factorial are all the options divided by 4 factorial. Those are the ones that I don't choose. And divided also by 9 factorial for every one of the ones that I choose, the arrangement of those. And so again, you should be able to do this on a calculator by doing the following. 15, and then combination of 9. And when you press the equal button, you should get the answer 5005. So the biggest thing is to figure out what is a permutation, or in this question, should I use a permutation or should I use a combination? And then the next difficult thing is figuring out the total and the number of items to choose from. And sometimes it's pretty straightforward, like in these 2 questions, but it can become a little bit complicated, as we will see in example number 4. In example number 3, we have the same coach, but instead of just picking a group of 9, he must line them up as well. So he must figure out, okay, I am not just picking them, but I'm also putting them in a specific lineup. And that means that the order of those 9 that he's choosing matters. So we can now figure out, using that, we can say that we have a permutation because the order does matter in this case. So we have a permutation of 9 players out of 15. And again, if you take your calculator and calculate the answer for this, then you get this big number, and that is almost 2 billion lineups. So he has 2 billion lineups to choose from if he wants to. And if you compare these two numbers, this is how many groups there are, but each one of these groups can be arranged in 9 factorial ways. And so when you take this number and multiply it by 9 factorial, you get this number. And so that's what you have to realize. That's the difference between the combination and a permutation. So now for example number 4. How many ways can a committee of 6 be chosen from 5 teachers and 7 students if, and I won't worry about this at this point. But before we go there, let's consider the fact what we have here. We have to choose a committee of 6. We have 5 teachers and 7 students to choose from, but we have to choose a committee of 6. And the question that you should ask always first before you start any of these questions is this a permutation or is this a combination? In other words, am I putting these in order? Will the order of my choice matter or will it not? And when you're selecting a committee, then the position within the committee is not important, is not meant to be important in here. It doesn't tell you that it is. And so if the position within the committee is not important, then the order doesn't matter here. What matters is that you choose a group of 6, a committee of 6. How they are chosen doesn't matter. They will still form a committee of 6. So that's the first thing that you have to recognize. So we know that this is a combination. We'll call it comb for short. And we know that we have 5 teachers to choose from and 7 students to choose from. Now we will look at how many ways are they all eligible. Sorry, how many ways can I form this committee if all of them are eligible? So here's the first question. So we've established that this is a combination. Now the next thing that we want to look at is to figure out what our answer is. We need to have a total then, and we need to have the number of elements that are chosen, or the number of items that are chosen, or in this case, people. So if you look at this question, how many people are there in total? If all of them are eligible, everybody's equally eligible, then how many items can I choose from? There are 5 teachers and 7 students, so there are 12 people in total to choose from. And how many do I want to choose? That's R. Since I want to make a committee of 6, the number of people that I do want to choose is 6. And so now I have my total, I have the number of items that I want to choose, and now I can figure out the number of ways that I can choose 6 out of 12. And that's the following. 12 for the total, C6, and that would be 12 factorial divided by 6 factorial times 12 minus 6 factorial. This would cancel out the ones that I'm not choosing, and this would cancel out the arrangements of the ones that I am still choosing. And here is how this would look like on the calculator. 12C6 is equal to 924. So I know that there are 924 possible committees of 6 out of the 12 that I can choose. So here's the next question then. What if there have to be 3 teachers and 3 students? I want to have 3 teachers and 3 students. Remember, this symbol means and. So again, this is a combination. And the reason why is because I am just simply choosing a number of 3 teachers out of the ones that I have and 3 students. I'm not putting them into a specific order. I'm not lining them up. I'm not arranging them. I'm just choosing a group of three teachers from the ones that I have. And the second thing that you have to recognize is that you can split this up into 2 different combinations. The first one is the combinations of the teachers alone, and this is the combination of the second of the students alone. But since you're multiplying every one of these ways with every one of these ways, you will get a total number of combination of both of them together. And that's where this and comes in. So 3 teachers would look like this. Since I have 5 teachers to choose from, I would take 5 and a combination of 3 of those 5. And since I have 7 students to choose from, I would take a combination of 3 students from those 7. And then I will multiply these ways with these ways to find out my total. On your calculator, you can figure out what these answers are, but this is what you should be getting. And make sure that you check that out to see if you get it correct and if maybe there is a mistake that I am making here. So the answer should be 350. So there are 350 ways to get 3 teachers and 3 students in a committee of 6 from the 12 people that I have. Now I have added here that let's look at the probability right away of that happening. Okay, so here's how this would look like. The probability of this happening, of getting 3 teachers and 3 students in a committee, that would have to be the desired outcome divided by the total number of outcomes. So what is the difference between those two? Well, the total outcome, that one has no restrictions. That one is just a number of ways that you can form a 6-person committee with anybody in it out of the 12 that I have. And that is the answer for question A. So the denominator is 924. Now, the numerator is the number of desired outcomes, which means the ones that satisfy this event here. 3 teachers and 3 students. And that was the answer for question B, which was 350. And so the probability to choose 3 teachers and 3 students in a 6-person committee, you would have to figure out, if this question was asked, you would have to figure out what is the total with no restriction, and then what is the specific one, what is the desired one with this restriction. Now this would be 25 over 66 simplified, and then you can figure out what that is in a percentage or in a decimal. So let's turn to the next question then. More than half of them must be teachers. So that means that you need to have 4 teachers at least and 2 students. If you have 4 teachers, then you have to have 2 students in that committee to make 6. But that's not the only option. There's another option. So the other option we would separate by an or, because they can't happen at the same time. So they are mutually exclusive. Remember that word. They're mutually exclusive. This one can happen, or the other choice would be to have 5 teachers and 1 student. Well, the other option could be to have 6 teachers and no student. But hang on, do I have 6 teachers? I don't. And so that is not an option. So the only 2 options that I have are 4 teachers and 2 students, or 5 teachers and 1 student. And so now I can go back and I can use the same method that I've done here, that I've used here. This would be a combination of 4 teachers out of 5, and this would be a combination of 2 students out of 7. Multiply those 2 together, do the same thing here with different numbers, and then add those answers together. And so before we type these numbers in, let us just think a little bit here. Choosing groups of 4 out of 5, how many possible ways can I choose groups of 4 from 5 elements? Well, hopefully it makes sense that I can choose that in 5 different ways. Why? Well, I can choose the first 4, then I can choose the first 2, third, and 5th. Then I can choose the first 2, and so on. There are 5 different ways that I can choose for a group of 4 out of 5. If that didn't make sense, don't worry about it. You can definitely use a calculator to figure that out, but some of you guys will catch on to that. And now the second one, 7C2. That is 21. That one is not as easy to figure out, so definitely use a calculator on that. Next one. This one also is easy to figure out. How many ways can I choose a group of 5 out of 5? Hopefully it makes sense that you can only choose a group of 5 out of 5 in one way. There's only one way to do that. And then the next one also should be easy to figure out. How many ways can I choose a group of 1 out of 7 people? Well, that is 7 times, 7 different ways, sorry. And so there are my numbers. Again, the reason why this is 5 is because I have 5 teachers. This is 4 because I need to choose 4. This is 7 because I have 7 students. And this is 2 because I want to choose 2 of those. And the same thing happens here, just with different numbers. So the answer should be 112 possible committees. And then the final question. At least one of them must, and that's where my typing apparently stopped, be a teacher. At least one of them must be a teacher. Okay, so you hear that word at least again, and that means that you have multiple options again. And so here are those multiple options. 1 teacher and 5 students, or 2 teachers and 4 students, or 3 teachers and 3 students. Oh, remember we had this one already, right? Or 4 teachers and 2, and we had that one too right here, 2 students, or, and so on. So I can either figure out all of these, but if you see all of this, you should recognize that there is an easier way. And here's how. These ones make up all the committees with the exception of one. What is that one? I have 5 teachers, 1 teacher and 5 students, 2 teachers and 4 students, 3 teachers and 3 students, 4 teachers and 2 students, 5 teachers and 1 student. That's as far as I can go. I can't do more than that. The other option, what is the other option besides those 1, 2, 3, 4, 5? What is the other option? The other option is that you have 6 students. That's the only other option. And now, since you know that the total number of options total number of these committees is 924. And you know that the only other option besides these 5, the 5th one I didn't put down anymore, the only other option besides these 5 is to have 6 students in there. Then why don't I just take my total number and subtract the number of ways to get 6 students specifically, only 6 students into that committee. And that should give me the rest. So let's write it like this. Total number of possible committees minus the one that is left out from all of these, which is the committee where you have 6 students, the committee of 6 students only. So this number was 924 from question A, and this number will be 7 students where I choose 6 out of those, a group of 6 out of those. Now, this is 924 minus, and you can check this out on a calculator, but you can also think about this again, choosing 6 people, a group of 6 out of 7. Hopefully it makes sense that there are 7 ways to do that. So that's 924 minus 7, and that gives you 914. And that is the answer for how many ways can I get at least 1 teacher to be on the committee. If you want to, you can verify this by adding or calculating each one of these out and then adding them together, and you will get the same answer. So if you see that there is a large amount of work that needs to be done, then there must always be an easier way to figure that out. And maybe you can just calculate the leftover ones and take that away from the total. And that finishes the video on the examples for a combinations and permutations, and identifying which one is which, and then how to use them, especially when you have a variety of items to pick from.